Okay, a postulate, or sometimes called an axiom, is a statement that is accepted as true without proof. It's a basic idea about points, lines, and planes that can be stated as postulates. So it's kind of like a rule or a definition. And like I said, a lot of these you've seen before. I've been mentioning them because they came up in chapter 1, so it shouldn't seem that new. Postulate 2.1, 2.2, 2.3, these numbers actually don't matter. These just have to do with whatever textbook it was pulled from. So don't worry about the numbers, just worry about the concept. So through any 2 points, there is exactly one line going through them. So here it shows point A and B. And for them to be collinear, the line doesn't even have to be drawn. You can draw it to show, but there's the line. So any 2 points. So for example, if I have a point on the board and a point on my desk, I can draw a line through those 2 points. Or wherever those 2 points are, you can draw a line through those 2 points. And a line contains at least 2 points. So we might have point L and point M. And then to name a point, just quickly reviewing, you'd use this little symbol and then you'd use the 2 points. Sometimes there's more than 2 points labeled on the line, but just choose 2 points to name it. Through any 3 non-collinear points, there is exactly one plane.
Here's an answer from Wikipedia.
Wonderful. Okay. Through any 3 non-collinear points, there's exactly one plane. So here's 3 non-collinear points, meaning they don't fall in a straight line, and you can draw out one plane. So even if the line or the plane is drawn or not, they're still coplanar. Okay. A plane contains at least 3 points, specifically 3 non-collinear points. So like A, B, C. So we got plane, and we'd name it by 3 points, A, B, C. Okay, next one. If 2 points lie on a plane, then the entire line is on that plane. So if you have point L and point M, let me get the door, then you have one line that is also on that plane. Okay, so 2 lines intersect. So if you have 2 lines that intersect like this, where do they intersect? They intersect at a point, and that point is labeled with a letter. So let's say point M. So 2 lines intersect at 1 point. And then we have 2 planes intersect at exactly, so 2 planes, this is a visual representation of 2 planes. You can see that they intersect right here, but these planes actually go on forever and ever and ever. They just can't draw that on the paper. So 2 planes actually intersect at a line. So 2 planes intersect at 1 line. Okay, next. Okay, another postulate, ruler postulate. Every point on a line can be paired with a real number. Let's zoom in a little bit, hold on. So here we have a line segment. It's paired up with a ruler to measure it. To measure it, we could say that this is from 2 to 5 would be 3 units plus another half, so we could say that this is 3.5 centimeters. The length of something can never be negative, distance can't be negative, just FYI. And then a blank is a statement or conjecture that has been proven to be true. This is theorem. You may have come across theorems in science. Have you heard, well, I guess it's called a theory in science. But same thing, it's a statement or conjecture. We've been working with conjecture, which is like based on a trend. It's an educated guess that has been proven to be true. So these are things that, remember, conjecture could have a counterexample. These are things that haven't been found to have a counterexample. It can be used as a reason to justify statements or proofs. Next, midpoint theorem. Again, we've come across this idea already. M is a midpoint of AB. So here is the segment AB. M is the midpoint here. And since M is the midpoint, then segment AM is congruent to AB. So segment AM is congruent to AB. And then since M is the midpoint, the length of AM is equal to the length of AB. So without that line, it's just referring to the length of AM and length of AB, segment AB. Why did we have to write that twice? Let me explain. The idea of congruence, we're going to see that a lot this year, but congruent could refer to not just segments, but it could refer to, let's say, triangles. So triangle ABC is congruent to DEF. And saying that those are congruent would mean that this side is equal to this one, and this one is equal to this one, and this side is equal to this side. There's a lot of equal parts here. There's even equal angles. This angle would be equal to this one, and referring to a lot of different parts being equal. When it's written like this, it's just referring to the length. So it just so happens in a segment that's congruent, the only thing that's equal is that length. So yeah. Okay. Next, now we're going to look at some examples. It says determine whether each statement is always, sometimes, or never true. And we're just going to be answering these based on the definitions that we just, or the postulates that we just wrote down. So based on these postulates, we're going to be answering whether these are true, sometimes, or never true. Determine whether each statement is always, sometimes, or never true. Line R contains only one point P. That would be never, because a line has to contain at least 2 points. A line contains at least 2 points. And yes, we're going to rewrite it because it'll help you remember them. Okay, next one, through 2 points there is exactly one line. True, by definition, always. One of the postulates says, through any 2 points there's exactly one line. Through any 2 points there is exactly one line. Okay, there's exactly one plane that contains non-collinear points A, B, and C. That would be always. So one of the definitions is, so when you have 3 non-collinear points, it makes a plane. So any 3 non-collinear points make one plane. Whether that plane is drawn or not, and we'll see that in some of these examples. And if points M, N, and P lie on plane Z, then they are collinear. Sometimes, maybe. So M, N, and P lie on plane Z. So it's saying these points would be collinear on a plane. Well, they could be non-collinear. It doesn't say, so this would be sometimes. Okay, number 5, the intersection of two planes can be a point. No, there would be a line. So never. Planes intersect at a line. Okay, now these are slightly different. They give us visuals over here to refer to. State the postulate that can be used to show each statement is true. So exactly one plane contains points F, B, and E. So I look at F, B, and E. Notice that those points don't seem to be on plane Q, but any 3 non-collinear points can make their own plane. So, true, any 3 non-collinear points make one plane. And then next it says that line BE lies on plane PQ. So we have point B and point E. Notice that there isn't a line drawn there, but through any 2 points there is one line, and that line would fall on the plane. And that was literally on our thing. So true again, well they're all true, but true if 2 points are on a plane, then the line is in the plane. Then the line is in the plane. Oh, there you go. Thanks. Okay, dos más. 2 more. The intersection of FG and AC is point B. Let's see. FG, this line, and AC, C, is point B. 2 lines intersect at a point. True. 2 lines intersect at one point. And then number 9, plane ABF and CDG intersect at line CD. We got ABF right here, CDG right here. They do intersect right here, but remember those planes go on forever and ever, and it intersects at a line. So true, 2 planes intersect at a line. Question, this comes up in one of the homework problems. 3 planes, what would 3 planes intersect at? Try to visualize it. You can visualize it different ways. 3 planes, I'm going to try to, I've never drawn this before, let's see how it comes out. So if I have 2 planes like, ooh, I don't know how this is going to come out. Okay, 2 planes right here. Ooh, this isn't going to come out well. Okay, I'm going to try to show you with my arms. So 3 planes, like you could have 2 going this way and then a 3rd one in the middle, so they could all intersect at one line, or if they were going different directions, they would intersect at a point. So it depends on how the orientation was. What else? Oh, something else. A proof in the form of a paragraph. Proof in the format of a paragraph. This, I don't know how I ended up in this bank, but it did, is a paragraph proof. There's no trick there. But if you get that question, that's the answer. And yeah, okay. So the rest of class, you have to do your homework. It'll probably be quick. If you have questions, let me know, or if you just want me to look it over before you submit it, let me know. If you finish it early, then work on Alex. We do have the laptop, so please use the laptops. Ready, set, go.